So today I want to talk about the new open source software release that I've been working on. This is Flowcoder. Let's talk about it. So I think most people who have used these coding agents for a while, they're really impressed by them, but they'll run into a few issues over and over again. So there's three issues that come to mind for me. One is that if you give the coding agent a very long, detailed protocol of what you want it to do, like let's say you wanted to take the task I have and decide how complex it is, and based on how complex it is, make a detailed plan for it with an appropriate amount of detail, and then based on that plan, implement it, and then take that implementation and write some tests and run those tests and debug the tests if they're failing. And then once you're done with all of that and everything's totally complete, go ahead and commit everything to Git. Right? Like, let's say you want a long protocol like this for your coding agent. Because like this is like a pretty standard thing you might do with any feature you implement in a new code base or in an existing code base. If you give it a really long protocol like this in a single prompt, typically these agents can't accurately hold on to all of it. Typically, they'll start hand-waving details or even skipping details altogether. They might forget steps if you give them like a lot of steps to do. And this was something I was experimenting with a lot earlier this year, trying to get these coding agents to get exactly the kind of behavior I wanted out of them. I would give them these really detailed protocols in their prompts, and they would work better than not at all, but they definitely were not working 100% of the time, and this would lead to issues sometimes. This would lead to me losing information because it wasn't committing stuff to Git, stuff like that, right? So that's one complaint, not accurately following really long, complex protocols in language. Second complaint. Sometimes I find myself repeating the same patterns of prompts over and over and over again, and that can be very tedious. Example 1. Let's say you have some bug in your code base. I have bug X in my code base. Don't edit any code. Analyze and diagnose the error. Or maybe like the program has this error, right? Same difference. And then I would often follow this up with a second prompt: take your diagnosis and analysis and fix the issue, right? So this is a very common chain of two prompts that I'll use over and over again when I'm implementing stuff. Sometimes trying to fix the issue doesn't fix the issue, and I have to kind of loop back to the first prompt. And then I have to kind of keep going between prompt 1 and prompt 2 and prompt 1 and prompt 2 over and over again until the bug is fixed. And this is just kind of tedious for me to have to do over and over again, and it would be nice if this was automated in some way. So this is sort of my second issue with these LLMs. It's just like you have these sort of patterns of prompts that you repeat over and over again. I'll give you guys a couple more examples of these. Implement the project specified in spec.md. Let's say you have some spec and you want the agent to implement the code base from the spec. You might give it a prompt like this. And then, to see if it actually did a good job, you might say something like, audit the implementation against spec.md to see if anything is missing. Store it in audit.md. And so this will tell us if the first prompt actually did its job thoroughly and captured every single detail in the spec that we wanted. And if the audit fails, then we want to go back and fix those issues, right? So maybe we might say, implement the project specified in spec.md. If audit.md exists, we already have a partial implementation, but the audit failed. So focus on the discrepancies laid out in the audit, right? So you can imagine that if you want to comprehensively implement some very complicated spec, you might want to go back and forth between these two prompts. Implement, audit, implement, audit, implement, audit. And it's a pretty effective process, but it's just a little tedious for the human to have to keep entering these prompts over and over again, especially if it goes on for like a long period of time. So these are a couple examples of repetitive workflows that would be nice to automate in some way. I'm sure there's like lots of other examples we could come up with. Everyone who uses these agents ends up finding sort of their own workflows that works well for them. So 2 issues so far. Let's summarize the 2 issues. My third complaint is that they don't run for that long a period of time. Maybe if you give it a prompt, it'll run for like 20, maybe 30 minutes. But if you want to run it overnight, that's a lot harder. If you want to have 8 hours of agent progress going while you're asleep at night, that's pretty difficult to do right now. I would love to address these 3 complaints. And so that is what Flowcoder is, and that's what I'm here to show you guys today. Flowcoder is an app that lets you visually build flowcharts of prompts and bash commands and other useful things that you might want an agent to undergo over and over again. Like you can set up your workflows, your protocols, or whatever, as a chain or flowchart of these different building blocks. And this lets us address all three of these issues. You have a long, complex protocol, don't encode it in language. Don't make one single prompt that has a million steps. Break it up into different building blocks. If you can break things down into a bunch of building blocks, you're going to get a lot more accuracy. Repetitive prompt patterns. If you have a loop between two prompts you're doing over and over again, and you want to store that in a flowchart that you can just call one time, and it just executes that loop over and over again until it finishes, that would save so much time for the human, right? Limitations on per prompt runs, well, you can set up flowcharts that can run for a really, really long period of time. You can set them to loop over and over again, even infinitely if you really want to. So we have some potential to actually do fully autonomous overnight runs with these flowcharts. We have a few examples, but I'm going to go ahead and just show you a little bit about how this looks in practice, okay? Sure, we can do a Notepad example. Notepad clone. Make a folder, np clone. Okay, so first of all, this session, by default, it pretty much behaves exactly like a standard Claude Code session. You can choose either Claude Code or Codex, depending on what your preferences are. I think that most likely different kinds of flowcharts will work better or worse for different coding agents. But you can choose either Claude Code or Codex. And so by default, when you're on this session panel, the session tab, you can just talk to the agent like a normal agent session. So, hi, what's your name? And it should say Claude. Okay, Claude Code is responding. Hi, hello, I'm Claude, an AI assistant. Okay, so we have the basic agent setup here. So far, this works exactly like a normal Claude Code session, but the interesting thing is that we can send special / commands that will launch a full flowchart of operations. That's the main thing that separates Flowcoder from just using Claude Code or Codex directly. So, let's do example 0. Design doc. Make a Win10 notepad clone. So, as you can see, I use that / command, and over here, we can see the flowchart execution. This is a really, really simple flowchart. This is example 0. This is as close to a hello world as I can get. So this is a very simple flowchart. Let's go ahead and take a look at what it's doing here. So we go to our first prompt. Don't implement anything yet. Create a design doc for this task, $1. $1 means argument substitution. It means you can pass an argument to this flowchart, and it will substitute this right here. So we passed this argument, make a Win10 notepad clone, and as you can see in the prompt, it substituted the argument, make a Win10 notepad clone. So you can use argument substitution with your flowcharts to get very flexible behavior out of them. That's one feature we have. So we have this prompt. It's going to just create a design document for whatever task we have. And then finally, we have a bash block that simply tags the most recent git commit with example 0 complete. One thing I should mention, I probably should have mentioned this up front, but these flowcharts have git integration built in. After every single flowchart block, we're going to automatically commit our changes. And if you want, you can set up your session to automatically push your changes to a specific GitHub repo and on a specific branch. But the default is simply to commit your changes after every block. And so this prompt happens, the agent responds, the changes are committed, so the design document is committed, and then that commit is tagged example 0 complete, and that's our full example 0 flowchart. Very simple. Let's see how it did. Framework Electron, UI layer, HTML, CSS, JS. Core features, we have multi-line text input with basic text editing, basic keyboard shortcuts, basic file operations, a basic menu bar, etc., etc. We have our architecture layout, etc., etc., etc. And so this is the design doc I created. Pretty simple prompt. This is like a very standard way people use coding agents. They'll have a prompt that's, make a spec, make a design doc, whatever. So now we're going to do example 1. These examples are set up to be run in order. Example 1, do until done. Takes one argument, which is a design document. And here we can see the flowchart. As you can see, this is a more interesting, more complex flowchart. So let's talk about what's going on here, okay? Do until done. So we have a couple loops here. You can see this big loop here. You can see this loop here, right? 2 different loops. So what's going on here? First prompt. So this is going to be very similar to the example that I talked about earlier, okay? First prompt. Fully implement the design doc. Here's the argument substitution. And document your progress in a progress report file, which is also based on argument substitution. If an audit file exists, it means that the task has been partially implemented already but has issues. Make sure you include a README for the end user to explain how to launch and use the program. And then here's the kicker. When you're done working, answer this question. Has the design doc been fully implemented? Now, here's what's cool. Okay, down here we have an output schema section. What does this do? This forces the agent to return a JSON object that assigns specific variables to whatever values with whatever types that you want. So here, I'm asking it to give me a JSON object with a single field fully implemented of type Boolean. Okay, and so what it's going to do, it's going to return some JSON object that either sets fully implemented equal to true or fully implemented equal to false. And this, my friends, is our first introduction to variables within Flowcoder. Your flowcharts can hold on to variables, they can manipulate variables, and most importantly, they can branch based on variables. That's the number one reason we have these variables. Okay, so this branch block evaluates fully implemented. If it's true, it takes the black arrow, and if it's false, it takes the blue arrow. So if it's not fully implemented, we're going to go here and loop. Progress report has the current progress towards implementing the design document. Continue fully implementing it. When you're done working, same question. Has it been fully implemented? And same output schema here. Okay? And so this is just going to keep looping this continue implementing prompt until the agent responds, actually, I have fully implemented this thing. Make sense? And then, once the agent decides it's fully implemented, are we going to trust it? No, we're not. We're going to audit it. So here we do a refresh. Refresh blocks simply reset the context of the agent, so you basically have a blank slate. Then we have this prompt. Audit the codebase against the original task description. In the design doc, write your audit out. Does the codebase fulfill the task requirements? And once again, we have this output schema that sets a variable requirements fulfilled. So the agent is going to set this variable. Is requirements fulfilled equal to true or false? If it's true, in this branch block here, we'll take this black arrow. Down here, tag us complete, and get out of there. But if it's false, we take the blue arrow back up here. And we say, fully implement this thing. By the way, there's an audit. Fix it. And so that's this double looping structure. Do until done. So this is an example of kind of one of the flowcharts that inspired me to make Flowcoder in the first place. Or one of the flowchart styles that inspired me to make Flowcoder in the first place. Because I gave it a very easy prompt, which is make a notepad clone, so I would not expect it to loop very much. Maybe it won't loop at all. But it has these looping capabilities. So we have a couple more examples, Example 2 and Example 3. I will probably not run those on stream simply because they are quite long. But you can run those yourself at home if you clone the repo and want to try out Flowcoder. Let me explain to you how these work. And there's more stuff to sort of be learned from these examples, which is why I want to go through them. So Example 2 is testing loop. It's kind of similar to Example 1 in a lot of ways. We start with the prompt, write a test suite for this code based on the design document. Make sure the test suite can be run with the command /runAllTests.sh. This command should produce exit code 0 if all tests pass and non-zero exit code otherwise. So far, the only variables that have been introduced have been ones created by a prompt, or created by an agent in response to a prompt. That's our only way of setting variables so far. We have these output schemas. But we have other ways of setting variables. Bash commands can output variables either just capturing the output of the bash command itself in a variable, or capturing the exit code of the bash command in a variable. Okay, so in this case, we'll be capturing the exit code. I'm calling this command run all tests and write out all the errors and stuff to test results.txt. Continue the workflow even if the command fails, and capture the exit code in a variable. Because we're going to use exit code equals 0 as our branch. Is exit code equal to 0? That means all our tests have passed, in which case we can put a completeness tag and get out of there. But if exit code is not equal to 0, then our tests have failed. We're going to take the blue arrow, we're going to do a refresh, and we're going to do this two-prompt pattern that I mentioned before. Diagnose all test failures without editing anything, and then fix all test failures. And then we loop back to running all tests. And so we have, once again, a nice little loop pattern. The main thing of interest here is being able to capture the exit code in a variable. One other interesting thing about this flowchart is that it shows us that not only can we do argument substitution, you guys remember argument substitution where we do this $1, right? We can also do variable substitution. Okay, we can put the values of our variables directly in these prompts. /runAllTests.sh returned exit code, brace, exit code. And that's how we do variable substitution. You might be wondering, why I didn't do bash style syntax for this when I did bash style syntax for the arguments. The answer is that I'm an idiot, and that I will be fixing this in the next version of Flowcoder. But right now we do variable substitution this way. You can inject variables in variable values in any of your prompts anywhere. Okay, so that's the main things to show you about example 2. Let's move on to example 3, which is the most complex flowchart, and I think introduces most of the other fundamental concepts that are important to Flowcoder. So basically this flowchart in a for loop is going to design a new feature for the project, implement it, audit it, and then test it. It's going to do all of that per feature, and then the number of features is whatever argument you pass in. So it's iterating over that number of features. Okay, we're seeing two kinds of blocks we haven't seen before. First of all, we have a variable block. So prompts can create variables through the JSON schemas. Bash blocks can create variables either through assigning the bash output to a variable or the exit code to a variable. Or we can just set a variable. That's what a variable blocks. You can just initialize or set any variable. Okay, so we're going to capture our argument here as max, and the intuition I want you guys to have as you look at this flowchart is we're implementing a for loop. That's the behavior I wanted to capture with this flowchart. We're implementing a for loop. So we set a max based on the argument substitution. Then we set a variable I equals 0. Wow. That's the first part of a for loop, isn't it? Crazy. For I equals 0, I less than max, I plus plus. Okay, so these are our three components of our for loop. And as I go through the loop, it'll make sense. We refresh the agent, and then we go to our prompt, read and understand the code base and all design docs, if any exist, create a plan for a new major feature, create a design doc, improvements design doc I. And then we have these purple blocks. What are these purple blocks? These are command blocks. These let you call flowcharts from within flowcharts. This is just like calling a function from within a function if you're coding. We have a similar stack mechanism that like a programming language would typically have for this. So when you call another flowchart, that flowchart goes on the stack. That flowchart finishes evaluating with its own variable scope, and then we come back to wherever we were executing from in our original flowchart. Okay, so we're going to run example 1, do until done, and we're going to pass in our new design document. Now you guys know why we're passing in a design document to example 1. And then we have example 2, which is testing loop. We're going to run the testing loop. Again, we're passing in the new design document. So, we make the design document, we do until done, we run the testing loop, and then we I++. That's the end of our for loop iteration, and then we go back to is I less than max. So does that make sense in terms of how the for loop is laid out here? And then once the for loop terminates, we do our tag completion once again. So, important concepts here. Variable blocks let you initialize and set variables. Command blocks let you call flowcharts from within flowcharts and let you pass whatever arguments to those flowcharts. And I think that's pretty much all the fundamental concepts of Flowcoder. From here, it's just a matter of designing the best flowcharts you can, and that's no easy matter. As you can see, these flowcharts are pretty expressive. Like, as it is, you get a lot of different performance out of just tuning a single prompt, right? If you're using Claude Code and you're typing in a prompt here, what you exactly say makes a lot of difference. You could say, make a Win10 notepad clone, or you could specify the features. Make sure it has file operations, word wrap, fonts, blah, blah, blah. Or you could make sure it's a certain technology stack. Make sure it's an Electron app. Or maybe you want to make sure that it's not over-engineered. Do not over-engineer. Yeah, sometimes you like prompt with like brain dead sentences like this and it actually works out pretty well. But like depending on exactly how you craft your prompt, you'll get something different. There's a lot of expressiveness on a per prompt basis with these agents. So imagine when you come to Flowcoder and you can build a whole flowchart of whatever prompts and whatever bash commands and whatever flowcharts calling other flowcharts. You can do all of that. That means that each flowchart is a highly, highly expressive machine. You can encode your exact workflow into it, depending on how you like to approach software engineering personally, and you'll get very different results. And so as I've been evolving my own flowcharts, I've been seeing some flowcharts get much better results, some get much worse results, and currently I'm in the process of sort of tuning those, trying to figure out what flowchart's going to be the best for my process. The examples shown here are definitely not optimized. These are all really basic prompts in each of these, but I think these basic loop patterns can be useful in constructing something potentially very good. But keep in mind that these examples are not optimized. I very much encourage you to take these as templates and then try to optimize them yourself based on your own prompting style. We do have one command here, all examples. This will run all 4 examples in a row if you want to see what like really long full autonomous behavior looks like. Depending on the project, this will easily run overnight and longer. If you want to like see really long autonomous behavior, you can run all examples, or you can even just like run EX2 and EX3. They'll be pretty long running examples for sure. And yeah, that's Flowcoder in a nutshell, guys. So the main 2 sort of use cases I see for Flowcoder is 1, just getting more productivity out of your vibe coding. That's very cool. And 2, doing research into developing better autonomous behavior. Like if you're an autonomous agent researcher, I'm hoping that this will be a tool that helps you out. This tool has some similarities to LangGraph Studio and OpenAI Agent Builder. The main difference is that the flowcharts in our app is built directly on top of other coding agents as opposed to raw LLM APIs. That means we get to bootstrap off of all of that intelligent behavior that Anthropic and OpenAI have already built into their models. Whereas LangGraph Studio and OpenAI Agent Builder, you build workflows off of raw LLM APIs. What's the next version going to have? So currently I'm using Flowcoder to try to implement the next Flowcoder. And that process is my main process for learning what flowcharts work well and what don't. So things I want for the next Flowcoder. So I want an Electron version of this, some UI improvements, but the really important things I want are I want a CLI so that you can execute a flowchart directly from a command line, which means that you can execute a flowchart from any random agentic app you might be developing. And I also want multi-agent / parallel workflows. Right now, every flowchart is for a single agent. It would be very cool to be able to set up parallelism, to be able to set off handoffs between Claude Code and Codex, things like that. So those are the main things I'm working on towards for the next version. That pretty much covers Flowcoder. I hope you guys enjoyed this. Click on the GitHub link if you are interested. Clone that repo and give it a shot. If you guys run into any issues, please post those issues on the GitHub. And yeah,